Alright, in this video we're going to be looking at the quiz that covered lessons 8.4 to 8.7. So let's see which one mine starts out with. So mine starts out with this one. It says, for the infinite series, determine if it is convergent or divergent. If it is convergent, give its sum. Okay, so first off, it's important that we recognize that this is an infinite series, because infinite series are the only ones that could converge or diverge. And the only ones that are convergent are geometric series. So if I could find that this is arithmetic, then I know that it would be divergent. But I can look at this one, I can see that going from 9 to 3, from 3 to 1, from 1 to 1/3, and then to 1/9, what we're doing is we're multiplying by 1/3 each time. And so that tells me that it is convergent. Oops, just need to do a C here. So it is convergent. It's because we're multiplying by 1/3. The way that you could tell if it's divergent, if it's a geometric series, is if the value for r is bigger than 1 or -1, or smaller than -1. Okay, so to find the sum, we're going to use, since it's a series here, to find the sum of a geometric series, we would take, oops, I have to put an S here. We would take our first term divided by 1 minus r. And in this one, our first term is 9. Our constant ratio is 1/3. So this would be the same. Now 1 is the same as 3 over 3, so this would be the same as 2/3. So to solve this, we would multiply the top and bottom by the reciprocal, which would be 3 over 2. So then your answer would be 27/2. Or if as a decimal, if you said 13.5, that would also be correct. Alright, so for this one it says find the sum of the numbers from 1 to 1,000. This is an arithmetic series. Remember, for an arithmetic series, if we know the first term and the last term, and if we know what our constant difference is, we would just do this. So if we know, if we know the number of terms, we would take the number of terms divided by 2 times your first term plus your last term. There we go. So we know that from 1 to 1,000 that there'd be 1,000 terms there. We know our first term is 1 and our last term is 1,000. So if you did this on your calculator, if you took 1,000 divided by 2, well, that's obviously 500. If we took 500 times 1,001, you get 500,500 as your answer. All right, so here this is a arithmetic series. I can tell that because the explicit formula here is arithmetic. So we can use that same formula that we just did. So we know that there's 12 terms in this series, so it would be 12 divided by 2. So now I need to figure out, well, what's our first term? So the first term is 8 times 1, minus 1. Well, 8 times 1 is 8. 8 minus 1 would be 7. So the first term would be 7. The last term, so to find the last term of the sequence, we would take 8 times 12 and subtract 1. Well, 8 times 12 is 96. 96 minus 1 is 95. So for this one, we would end up taking 12 divided by 2, or 6, times 7 plus 95, or 102. And when you do that, you get 612 as your answer. So that's your answer for number 3. Okay, so for this one is number 4. It says Sally's birthday is June 21st. On her golden birthday, when she turns 21, her parents will give her 1 cent on the first day of the month and double the amount they give her on each day. So the second day she'll get 2 cents, the third day 4 cents, and so on. If you were to add together all the money she would get from the first of the month to her birthday, the 21st day of the month, how much money would her total gift be? Okay, so what's happening here is we're doubling, we're multiplying each one by 2. So this is a geometric series. Now it's not an infinite geometric series. Okay, this is a finite geometric series. So to find the sum, we would just take our first term times 1 minus r to the nth power divided by 1 minus r. So our first term in this case is 1 cent, 0.01. Remember, we're doubling it each time, and we're going to do that for 21 days. And then we'll divide that by 1 minus 2, because that'll just be -1 there. So when I do this on my calculator, we end up getting as our answer 20,000 $971.51. So just under $21,000 is how much total she would get for her 21st birthday, which is kind of ironic. That for her 21st birthday, she just end up getting just under $21,000. All right. So here's another geometric series. So we're going to use that same formula that we just talked about. So we need to know our first term. Our first term would be the 12,000. I'm sorry, 1,200. That's not 12,000. It's 1,200 or 1,200. So that'll be 1 minus my constant ratio, which is 1/2, to the nth power. And this would, since there's an 8 on top of the summation notation, the sigma there, that tells me that there's a total of 8 numbers in the series. So we take 1,200 times 1 minus 0.5 to the 8th power and divide that by 1 minus 0.5. And when we do that on your calculator, you end up getting $2,390, or $2,390.625, which we'll just round in nearest tenth. We'll just leave it as 2,090.6. 2,390.6 would be your answer there. Okay, just a few more left here. So this is my 6th one. It says for the following infinite series. So again, it's an infinite series there. Determine if it is convergent or divergent. If they are convergent, give its sum. So going from 4 to 8, we're adding 4, and from 8 to 12, we're adding 4, and so on. So the fact that we are adding 4 each time tells me this is an arithmetic series. Arithmetic series are always divergent, and so there is no sum. They just keep getting bigger and bigger and bigger, or if we were subtracting, it would be getting smaller and smaller and smaller. Here's another one. Where we're going from 20 to 24, from 24 to 28.8, from 28.8 to 34.56. So what's happening is if I took 24 divided by 20, I get 1.2. And if I took 28.8 divided by 24, I'd also get 1.2, and so on. So this, we're multiplying our constant ratio is 1.2. So you might think that, oh, that means we're going to have a sum here. Well, that's not the case. If your value for r is bigger than 1 or smaller than -1, in a geometric series, it's divergent. And that's what's happening here. This would be divergent. And so for the sum, we would say none. All right, so here for this last one, we're just going to determine whether each of these are arithmetic, geometric, or neither. So for this first one, going from 2 to 5, if I add 3 going from 2 to 5, or 2 to 5, I'd add 3. 5 to 8, I'd also add 3. 8 to 11, I'd also add 3. So that's an arithmetic series. For letter B here, 4 times -2 is -8. -8 times -2 is 16. 16 times -2 would be -32. So that is geometric. For this one, if you're not sure, we could take 81 divided by 243 and you get 0.3 repeating. Or 243 divided by 3 would be 81. Well, guess what? 81 divided by 3, or 81 times 1/3 is 27. 1/3 of 27, or 27 divided by 3 would be 9. So here, this is geometric. We're multiplying by 1/3 each time. And lastly, going from -8 to -5, we would add 3. -5 plus 3 would be -2. -2 plus 3 would be 1. And so that we're adding each time, so that'd be arithmetic. So none of those are neither. These are all these ended up being arithmetic and geometric. So that's it. So hopefully that answered the questions that you might have had from that part of the quiz. But just as usual, if you have any questions beyond what this video might have answered, please make sure you reach out to me before the test, and that way you can make sure you know what to do.